in this problem, we're asked to find sine of alpha minus beta and tangent of alpha minus beta. So to do that, I'm going to need, for this one, the identity includes a sine of alpha, sine of beta, and I also need cosine of alpha and cosine of beta for those equations. So just as a reminder, our identity for sine of alpha minus beta is equal to sine of alpha times cosine of beta minus, it keeps the same sign, and then we switch the trig functions, so cosine of alpha times sine of beta. So our cosines are sandwiched in between during our sine function, and we keep the sign and flip the trig functions. And for tangent, our identity is alpha is tangent of alpha minus, keep the same sign in the numerator, and in the denominator we flip the sign and do multiplication. All right, so those are our two equations. So to get these two, I'm going to need sine of alpha, cosine of alpha, tangent of alpha, and sine of beta, cosine of beta, and tangent of beta. So I need all 6 of those trig functions. And I'm not given alpha and beta directly. I'm just given this hint about how to find the other trig functions. So I can't necessarily find alpha and beta, the actual angle, but we can use the quadrant analysis. We have the quadrant and we have one of the trig functions, so we can find the other 6. So, or other 5. Okay, so our first hint is that cosecant of alpha equals 29 over 20. And that tells me cosecant is r over y. So r is 29 and y is 20. And from that, I'm able to find x. X is the square root of r squared minus y squared. So that is square root of 29 squared minus 20 squared. And it's in quadrant 1, so I know it's going to be positive. And that gives me, I'm going to put that in the calculator. And I get 21. So now I have x, y, and r, so I can find all the trig functions that I need. And I need cosine of alpha, which is x over r, so that's 21 over 29. I need sine of alpha, which is y over r, so that's 20 over 29. And I need tangent of alpha, which is y over x, or I can just do sine over cosine, and that is 20 over 21. And then I need my betas, and here's my hint for my betas. So for beta, I'm given that cosine of beta equals negative 12 over 37, which tells me x is negative 12 and r is 37. And that gives me y equal to the square root of r squared minus x squared. So that's 37 squared minus 12 squared, which gives me, again, I'm going to use the calculator for that one. And after I put it on my calculator, I get that's 35. It's in quadrant 2, and it's a y, so that is a positive also. Okay, so I have cosine of beta. Now I need sine of beta. So that's the y over r, so that is 35 over 37. And I need tangent of beta, which is y over x, or sine over cosine, which is negative 35 over 12. All right, moving on to, okay, so this one was quadrant 2, this one was quadrant 1. That gave me the sine. Okay, now moving on to plugging into the identities. So I have all the information I need now. Now I just need to find those identities. So for A, we need to find sine of alpha minus beta. And that identity is, always start with the sine, and sine switches the identities and sandwiches the cosines in the middle. Keeps the same sign, and then I do cosine again. And alpha beta always stays in the same spot. And then I get sine of alpha. So I don't know what alpha is, but I do know sine of alpha. Sine of alpha is right here. So that is 20 over 29. And again, I don't know what beta is, but I know cosine of beta, which is, I'm going to do parentheses since it has a negative and I don't want to mistake that as a minus sign. Minus, and then the cosine of alpha is up here. Again, I don't know what alpha is, but I know the cosine of alpha is 21 over 29. And I don't know what beta is, but I know sine of beta is 35 over 37. And now it is a calculator issue again. So I would take my calculator and multiply 20 times negative 12 all over 37 times 29. They both have the same common denominator, actually, 37 times 29. And then minus 21 times 35. So getting my calculator out to do that math, I'm going to do the entire numerator first, hit enter, and then divide by the product of 37 and 29. And I get negative 975 over 1073. So that's sine. Now repeating that process for part B, I'm looking for tangent of alpha minus beta, and that identity is tangent of alpha, keep the same sign, and then minus tangent of beta in the numerator. And the denominator, I have 1 minus the product of those two tangents. Oh, I'm sorry, plus. So I keep the same sign in the numerator and flip the sign for the denominator. Okay. So tangent of alpha, again, I don't know what alpha is, but I do know that tangent of alpha is right here. And that is 20 over 21. And I'm going to need tangent of alpha again down here. So that's 20 over 21. And tangent of beta, I have that one twice, and that's right here. That is going to be a negative 35 over 12. And that's a negative 35 over 12. And that equals, let's see here. So we need to get a common denominator. So I'm going to do 20 times 12. This is minus a negative, so that's really a positive. So I'll do plus 35 times 21 all over 12 times 21. It's a complex fraction, so that all over that's a minus 20 times negative 35 gives me a 20 times 35 And the denominator is 12 times 21 again. So instead of 1, I'm going to write 12 times 21 over 12 times 21. And plugging that into my calculator, in the numerator, I get negative 975. Sorry, positive 975. And in the denominator, I get 448, negative 448. That is my final answer for part B. So that 12 times 21, that actually was a common denominator to both parts of that complex fraction, so that canceled out. All right, so that's a bit of a long problem, but I think that gets it all on the screen right there.